okay, 2x minus 5, and let's say when x approaches 3, so we want to find the limit of 2x minus 5 when x approaches 3. What does this equal to? Anyone?
1.
Excellent. Good. We are already given epsilon 0.7. So we always start from the function, which is 2x minus 5. We have to write the whole thing, but now quickly let's determine delta. So minus 1 in absolute value, less than 0.7. We combine like terms and we have 2x minus 6, less than 0.7. We factor out 2, we get x minus 3. We still have to continue writing this. That's the correct step. Now this is 2, and it's x minus 3. So x minus 3 less than 0.7 divided by 2, and that's your delta. So we had several examples. I highly recommend rewatch, redo those, so you don't have any difficulties with it. That's all you need to do. But of course, for a much easier function, I created a more difficult linear function than the one you have there. Welcome back.
Is the absolute value of x minus 3 is less than 0.7?
We are asked to find delta.
Okay.
You are not putting in anything but, in my case, in my example, then 0.7 over 2. Nothing else. No equal symbol, no delta, no less than, no nothing. It says, for the given function, find delta, given epsilon. Andrew, we are working on 2.4, the first problem on the quiz.
Yes.
Welcome back.
No, I've just been working on the problem.
Okay. No, I said, I'm sorry, Aaron. I meant Aaron. I'm sorry, forgive me.
Yeah.
I didn't mean Andrew, sorry. The same idea for question number 2, but for question number 2, epsilon is not given. So the answer has to be written something like this. 10 epsilon with uppercase E, but lowercase p, epsilon, let's say, over 15, or 30, or 150. I'm sorry. I just went with 115. I just made stuff up. I just didn't want it to be simplified, so we have to put it fully simplified. So if it's a fraction, just write whatever, epsilon over whatever. If it's not a fraction, just write 2 epsilon, for example. Okay. Do you think we need any help with problem 3? We had like 4 piecewise defined functions. Graph it step by step, and just say that the function is continuous everywhere, or if it is not continuous everywhere, just put 5, 3. It's not continuous at 5, it's not continuous at 3. But it should be 3, 5 because it should be in order. Do you think we can finish this up by tonight? Do you think you need more time? Are we okay with this? No, you have time till tonight. There are 3 questions. Do you need extra help here, or other hints or anything for these 3 questions?
Professor?
Yes, please.
Is it just those 3 questions on 2.3?
This is on 2.4.
Oh, okay. Thank you.
Yeah. Yeah, I didn't write anything for 2.5 because we just finished it. Okay, Alden, are you there? Just making sure. Okay, very good. Okay, so we move on. Do you need more hints for these 3 problems? Anyone? Anyone? Okay. You can stop me if you need more help on any of those. But let's move on. The next section, 2.6, deals with infinite limits. Actually, limits at infinity. We did that. Sorry about that. So let me tell you what I meant by that. I'm going to erase it. So we have limit as x approaches 1 from the left, from 1 over x minus 1. 1 from the left is 0.9. We know that this is 1 divided by 0. We know it has to be either DNE or positive or negative infinity. So these are the infinite limits. So the result is infinity. In this case, it's negative infinity. That we did. Now we want to discuss limits at infinity, when x approaches, not a number, but infinity. So that's our next step, because this one was already done in a previous section. Okay, so first let's establish a few things before we look at problems. Assuming that r is a number strictly greater than 0, what do you think about limit of 1 over x to r when x approaches infinity? I'll put in parentheses because I'm lazy to write it again, or negative infinity. This is extremely important because if this power is negative, it goes back to the numerator. So it's a different story. So the power of x is in the denominator, and its power is a positive number. Again, if it's negative, then I can bring it up to the numerator. So what do you think this limit will be? And you can say, wait a minute, let's start with r being something we know. Okay, I completely agree with that. If you say that, that's 1 over x. We know the graph of 1 over x. This is the graph of 1 over x, and we have to have it in the back of our minds at all times for many reasons. So this is the graph of 1 over x. So as x approaches infinity, even if I put a power on this, it will go faster to that than if I just put 1, power 1. So what do you think the answer will be here? By simply looking at the graph, I'm sure you will come up with the correct answer. What do we say? What do we write here? Anyone? Okay, follow my marker. As x approaches infinity, the function values get closer and closer, closer and closer, to what?
0.
Thank you very much. Excellent. Which automatically says, because it's the same on both sides, this automatically implies y equals 0 is a horizontal asymptote. Guaranteed. Keeping that in mind, and now before we look at some graphs for a moment, let's look at this graph. It's problem 3. So limit as x approaches infinity. as x approaches infinity, the function values get closer and closer, closer and closer to negative 2. As x approaches negative infinity, the function values get closer and closer, closer and closer to 2. X from approaches 1 from either side. Either side of 1, the function value, this is what we already know, infinite limits, goes to infinity. The limit from either side of 3, the limit from either side of 3, as x approaches 3 from either side, it's negative infinity. The equations of the asymptotes, 4 asymptotes, x equals 1, x equals 3, x equals negative 2 only at infinity, and x equals 2 only at negative infinity.
What do you mean y equals 2 and negative 2 for the horizontal asymptotes?
You said y?
Yeah.
It's the same.
She meant y is in the y value, not y is
Oh, okay.
like y equals 2 and y equals negative 2 for the graph.
For the horizontal asymptote.
Okay, let me graph something similar to this. Very good question. Let's do that. So the graph does this. X equals 1. X equals 3. And it does this. So this is, and of course I cannot graph a line, just one piece of it. Y equals 2 horizontal asymptote at negative infinity only. But on the other side, the graph does this. So the graph is this.
No, right, I was just saying, because you were saying, for the horizontal asymptotes, you were saying x equals 2 and x equals negative 2.
Oh, I didn't say y?
Yeah. That was,
Oh, I'm sorry. I meant y, of course.
Yeah, it was just that.
I got carried away.
It's okay.
My mistake. Sorry about that. I meant y equals negative 2. Oops. Y equals negative 2 is a horizontal asymptote at infinity only. This one is y equals 2 is a horizontal asymptote at negative infinity only. So it means when x goes to approaches negative infinity, the function values approach 2. When x approaches infinity, the function values approach negative 2. Is that okay? And now I would like to look at any problem, so I can show you how we determine this, which we could not do this in pre-calculus, but I did show my students the concept in pre-calculus. But here we are not using that step by step. I mean, a different type of procedure. We are using the calculus procedure here, what we just learned. So I'm going to start with, let's say, 18. Limit t approaches negative infinity from 6t squared plus t minus 5, everything divided by 9 minus 2t squared. Any questions before we continue? Anyone? Can anyone give us the answer right away from pre-calculus? It's okay if you don't remember. It's okay. Can anyone give us the answer from pre-calc immediately? You don't have to.
Is it negative 6 over 2?
Over negative 2. Very good. Why? Because the numerator is degree 2, the denominator has degree 2. It's always the ratio of the leading coefficient over the leading coefficient. But that was in pre-calc. How do we get to that here? Here's how we do it. Again, can anyone tell me what is the degree of the top?
2.
2. If the degree of the top is 2, I will factor out t squared. What is the degree of the denominator? 2. If that's the case, I will factor out the degree. I know you will say, but t squared is not a common factor at the top, and t squared is not a common factor at the bottom. I completely agree. I can factor out anything I want from anything I want as long as the rest is legitimate. What I'm saying is, from 1 minus x, can I factor out x to the 5th? Of course I can. As long as I write 1 over x to the 5th minus 1 over x to the 4th, I'm fine. Of course. X to the 5th times 1 over x to the 5th is 1, and x to the 5th divided by x to the 4th is x. So I can factor out as I please, whatever I please, as long as what I put inside matches. So if I want to go back and check, I get back 1 minus x. So the same thing in our problem. I have to factor out the degree, which is squared, or t squared in other words. And as long as I come up with 3 terms that match, and 2 terms that match, 9 minus 2t squared. So what do we have? I need 3 terms here and 2 terms here.
On the top, it would be 6 plus t minus 5 over t.
So you want minus 5 over t squared, I agree. And I agree with 1 over t. Is that correct? As long as it matches. Let's try. Is t squared times t that? Yes. Is t squared over t that? Yes. Is t squared over 5 times 5 over t squared that? Yes. Good. What do we have in the denominator?
Over t squared minus 2.
Excellent. Now, of course, what do you think I'm going to do next?
Also like terms.
I covered so you can answer quickly. What do you think I'm... Of course, I'm going to get rid of these. That was the whole purpose. So then now, please tell me, when t approaches negative infinity based on what we just discussed, where does this piece go? Where does this piece go? And where does this piece go?
Approaches 0.
Thank you very much. Therefore, the answer is
-3.
excellent. Y equals -3, since this is a rational function, will have the same asymptote guaranteed on both sides, is a horizontal asymptote. If it's not a pure exponential polynomial over polynomial, I cannot conclude that it's -3 at both ends. I have to say it's -3 when x approaches negative infinity. But such a function will always have the same asymptote, left and right. Any questions so far? Any questions? Look at how many examples are here, or problems are here, of this different types, of course. Okay, so let's look at another one.